If you missed some keywords because you were late, that's no big deal. Either take the point hit or watch the video and tell me the keywords, from the video. But don't get the keywords from somebody else. I get a log. This Google automatically gives me a spreadsheet that says this is who logged in, this is when they logged in, this is when they logged out. So, like I said, don't get the words from somebody else. Take the hit or watch the video. That would be the better option, right? See what you missed. All right. What you can't see as I'm sitting here talking to you is I'm pulling up the chapter 3 PowerPoint. So I'm not just sitting here talking to you. I'm also getting the next PowerPoint ready. And 1 second. Bear with me. I'm sorry. Any questions while I'm getting this pulled up? All right. So I'll remind you, this is the last chapter.
I have a question.
Yes.
How do we watch the video? Is it gonna be like posted on like Google Classroom or something?
Yes. Every day after a lecture, I always post an announcement on Google Classroom that has the link for the video and a link for the questions, and then other pertinent information for the day. So yeah, and when I post it to Google Classroom, you should automatically get an email.
All right, thank you.
You're welcome. Good question. Anybody else? All right. Let's see. You should be seeing my screen right now. I'll be pulling up. Can someone please confirm that you can see the PowerPoint? Okay, thank you. So yeah, anyway, really quick reminder, this is the last chapter that's going to be on the first exam, meaning once we're done with this chapter, we're going to do the exam. So I would say by Friday, by the next time we meet, we'll have an idea of when our exam is going to be. So I'm going to assume almost definitely it's going to be next week. The question is when, Monday, Wednesday, or Friday. So keep that in the back of your mind. Also, if you have any requests, go ahead and email me and say, hey, I definitely don't want to do it on Wednesday, or, oh, I would love to do it on a Friday. Whatever the case may be, go ahead and send me a request if you have any. But here we go. Chapter 3. So the last thing we talked about was chemistry, right? We were talking about atoms and like a single molecule, like what makes up a molecular molecule, excuse me, covalent, we talked about covalent bonds that make up a molecule or ions that make up a ionic compound. Now we're going to take this a step further. Now that you know about molecules in general and chemistry in general, we're going to get really specific and talk about some specific molecules that are very, very important for life. Your chapters always start off with this little guessing game, or some pictures where it's like, hey, this is why this is relevant. So when you see, or speaking of biological molecules, I'm going to see if you can guess this one. This picture here has got a picture of some meat. You can see this person's hair. So any ideas what this picture might represent? And again, I would assume you guys don't even know the biological molecules yet, but you know this molecule. You just might not know it's a biological molecule. What kind of stuff would you find in meat? Also in hair?
Protein?
Yeah, protein. So yes, in this chapter, you're going to learn about protein. Now, this little kid, I bet he wasn't even allowed to do that, little jerk. Anyway, what this bar of chocolate is solid, correct? But if you look at this guy's face and look at this guy's fingers, clearly it has melted. And the reason that is because certain fats are solid in room temperature, and then they are liquid when you apply just a little bit of heat to them. Specifically, body heat is enough to do that. And you're going to learn a little bit about fats and what makes some fats able to do that and some fats where they don't do that. Now, here's a tough one. I'm going to ask once, but then I'll move forward. Can anybody guess what molecule might be represented in this picture? And I don't really expect anybody to get it unless they've read the book, because this is a stretch. Because it's an elephant. All right, that's okay. Your book was talking about DNA. Specifically, I guess, if you don't focus on the elephants, it kind of makes a little bit of sense. I think if I remember correctly, your book was saying that if you were to look at the DNA of an elephant, right, look at the molecule itself, not the code, not the A's and the C's and the T's and the G's and the order that it's in, but just the molecule itself, it would look just like your DNA as a human. It would look like just like the DNA in this tree, and just like the DNA in this grass, because all DNA on all forms of life, it's the same molecule. So anyway, that's the introduction. Any questions about that? All right. As always, your book starts off with this little section, the biology and society. Usually I skip it, but in this case, it's going to be some information that will actually be valuable for you on the exam. So let's talk about it. Lactose. I'm sure you guys have heard of lactose, or more specifically, you've heard of people who are lactose intolerant. So you'll get a little bit of an understanding of what that means. Lactose is the main sugar found in milk. So that's what it is. I'm sure you've heard it. That's what it is. It is the main sugar found in milk. There's other ones, but that's the main one. Therefore, lactose intolerance is simply the inability to digest it, right? So what normally happens for people who are not lactose intolerant, they drink milk or eat dairy. They get that sugar in them, and they have something called an enzyme. Specifically, that enzyme is called lactase, and it breaks down the sugar. And in this chapter, you're going to learn specifically what lactase is, but more importantly, you're going to learn what an enzyme is. So we'll come back to that. So anyway, these enzymes that you have, if you're not lactose intolerant, they break down the sugar into, when I say break down, I mean break it down, right? You're breaking down the molecule into other smaller molecules. And those other smaller molecules are then able to be absorbed in your intestines, which are then broken down by bacteria. Oh, excuse me. I misread this. So far what I've told you is correct, but I've misread this and I was about to say it incorrectly. So again, normally it's broken down by lactase. But if you're lactose intolerant, instead of that happening, it goes to your intestines without being broken down by your own enzymes. So instead, you've got bacteria in you. Well, everybody has bacteria in them, including, lactose tolerant and intolerant people. And this bacteria is the thing that breaks down the lactose, instead of your enzyme. And what happens when that happens? Well, that produces gas, that produces discomfort. So that's why lactose intolerance is an uncomfortable thing, because your lactose is being broken down by bacteria instead of enzymes. So again, in this chapter, you're going to learn exactly what an enzyme is. I'm going to go through this really quickly because this part definitely won't be on the exam. But yeah, lactose intolerance is basically two simple things to do if you have lactose intolerance. You either don't eat lactose or you take a pill that puts those enzymes in your belly, right? So you can break it down. All right. Now we'll jump into the important stuff. This chapter is broken down into two main bullet points: organic compounds and large biological molecules. Before we get started, I'll give you the other word for attendance, and it will be this one here: blocks. Which is good. We kind of talked about blocks earlier too. We talked about Lego blocks. So yeah, blocks is this next word for attendance. Anyway, organic compounds. Let's get started. As you already know from the last chapter, cells are mostly water, and I told you needed to know that. Specifically, the number that your book gave, 70 to 95% water. You are almost entirely water. Your cells are. So if we take away the water, because we've already had a discussion about water, what's left? Well, almost entirely, not entirely, but almost entirely, if you take away the water, what you would have left is a bunch of carbon-based molecules. And if you've had the lab, now you know why you kept drawing a bunch of carbon-based molecules, is because that's what we're dealing with in biology, mostly. So as you also learned in lab, or like you will learn in lab, carbon forms large, complex, diverse molecules that are necessary for life. And the basic answer the basic reasoning for that, just so you know, not that I'm going to ask you, is carbon makes 4 bonds. And, oxygen only does 2, nitrogen does 3, hydrogen does 1. So that's a pretty big thing, the fact that it does 4 bonds. That's, as far as we're concerned, that's the most bonds that anything else makes that we talk about. So if you can make a lot of bonds, you can make a lot of different shapes, right? You make a bunch of diverse molecules. Then that brings us to this word right here, organic compounds. Everything I've been talking about, basically, in this slide are organic compounds, which are carbon-based molecules. I probably will not ask you that on the exam, but now you know what an organic compound is. It has nothing to do with organic farming, right? It's not organic compounds has nothing to do with, oh yeah, I'm going to Kroger, I'm going to get some organic, I don't know, organic zucchini, nothing like that. So any questions? Okay, so since organic compounds are carbon-based compounds, let's talk about carbon. And again, if you've had the lab, this might be a little bit of a review. And if you have it today, then that will be your review. Like I just said, carbon makes 4 covalent bonds. And because of this, it makes many different carbon skeletons that vary in their size and their branching pattern. You don't need to write any of this down. This is all an introduction. If there's anything you need to know, it would be this bullet point right here, that carbon makes 4 bonds. But even in my opinion, that's something you wouldn't even need to memorize because, I mean, you're going to be very familiar with it. So, but anyway, yeah, let's talk about these many different carbon skeletons. These are just 4 examples. There's many, many examples. You guys wrote your own examples in the lab, or you will do it in lab. Your book points out that carbon skeletons vary in length. So here we have 2 carbons, and it could go on to hundreds of carbons, right? You could have the same molecule, but with hundreds of carbons. Yeah, so that's one thing. Carbon skeletons also may have double bonds, which can vary in the location. So again, your book has this one example of a double bond right there. And this is not trivial. You might think it's trivial, like, okay, big deal. It has a double bond instead of a single bond. Therefore, it's, it doesn't have these hydrogens attached to it because it already has its 4 bonds. But that, again, it's not trivial. That makes a difference as far as chemistry is concerned. And we'll talk about why later. Carbon skeletons may be branched or unbranched. So, these 2 up here, the examples that I've shown you, they're all straight, right? Straight carbon skeletons. This one, it's not, right? This one's got it has like a phallic appearance to it. And, it could keep going this way. And then that one could branch out this way. It's just basically because of the fact that it makes 4 bonds, it can go every which way. And then finally, your book also points out that carbon skeletons may also be arranged in rings. So it doesn't have to be long, skinny chains. It doesn't have to be weird shapes. It could also be rings. Nothing on this slide will be on the exam. This is just stuff to keep in your mind as we move forward and we talk about all these molecules that we'll be talking about this chapter. So, are there any questions about this slide? All right. Carbon can bond with all kinds of other elements. Mostly it's bonding with these, which makes sense. And I told you in the last chapter, you need to know this. These are the big 4, right? Carbon, hydrogen, oxygen, nitrogen. You just need to know the big 4. And there it's come up again. Your book gives an example. You don't need to memorize this example, but methane is a great example of a carbon molecule. Here you have the 1 carbon, and it is attached, each one of its 4 bonds. It is attached to these hydrogens. So its chemical formula is CH4. And yeah, your book gives a little bit more information about it. It's one of the most simple organic compounds. It's very abundant in natural gas. Where is it produced? It's produced by prokaryotes, which are basically bacteria in swamps. And that's where we get swamp gas. And again, it's also produced by digestive tracts of grazing animals such as cows. None of that's going to be on the exam. Methane is just an example. Any questions about that? All right. This kind of goes back to last chapter when I showed you a picture of formaldehyde, and there's all these different ways of drawing it. Well, here you go again. Different ways of drawing it. Here's the structural formula. Here's the ball and stick model. Here's the space filling model. You don't need to know that. The point is, if I keep drawing something like this, and then for some reason you're interested in it and you Google it, I'm like, I really am interested in methane. So exciting. And then you Google it and you see something like this. I don't want you to think, oh, that Mr. D, he's full of it because he drew this, not this. But, same thing, different way of representing it. Okay. Let's talk about some of these larger organic compounds. They are the main molecules that are found in gasoline. Octane, for example, that is a chain of carbons that has the hydrogens next to them that are hydrogens bonded to them, right? That's octane. That's what you find in gasoline. That's what makes your car go vroom. It's also the same fuels found in your body, right? Here's dietary fat. And you can see it's very similar. It looks like dietary fat has 3 different octanes attached to something, right? And if you described it that way, you wouldn't be exactly wrong. You'd be close enough, which goes back to what we talked about in chapter 1, this idea of structure and function. I said it would keep coming up. Well, here's a great example of that. The structure of these things are similar, and their function is to, well, store energy until it's needed, in which case you break it down and it releases energy. So there you go. Structure, function. You definitely don't need to know anything about octane, and we're going to talk about dietary fat in more detail later. So as far as we're concerned, this slide is not important for the exam. Any questions about this slide? All right, less than a minute left. Oh, and again, this is just what I was saying earlier. So this is octane up here at the top, up here. And this is one of those fat molecules, or a part of the fat molecule. You can see how similar it is, structure, function. All right, the next, I guess the last word for attendance is going to be groups. The last word for attendance is groups. And when we come back on Friday, this is where we will pick up. So don't forget to send me your emails with attendance. I apologize. I know this seems to happen at least once a day with some of you, and I really am sorry. But if you missed any words, you just get partial credit. And it's just there to make sure you pay attention. And you're not getting punished if, like, you get kicked out or your cat starts puking on your bed and you have to get up and you miss something. Because I'm giving you the video, so you can watch the video later. So again, it's not a punishment. I just want to make sure that you're actually paying attention to the lecture. So I guess that's that. Does anybody have any questions?
Can you please tell me what class that the lab is in again, please?
Yes, great question. Yeah, it's the lab will be held in H205. So that's the second floor of Hamblin. It's closer, like if you're looking at the building, it would be closer to the library than it would be the highway.
Okay, thank you.
You're welcome.
If we watch like the video, if you're late, if you watch the video and you say the keywords, can we just turn it in or no?
Actually, yeah. Let's do that, because for those of you who are here, and I know that you're here, like you, and I'm recording this and I get a spreadsheet. If I know you're here, then yeah, let's do that. That'll be a good change, at least for today. You can just give me the words if you are here right now. Of course, anybody else watching this who is not here right now, you'll have to do the questions. But yeah, sure. Good question and good idea.
Thank you.
Anybody else? All right. I'll try to be online for lab today. I apologize to everybody for being slow with emails and grading. I'm just really under the weather, and I'm also not the only one in the house that has the COVID. So dealing with a lot over here. So that's it. I will either see you online at lab, or I will see you online for office hours, or I will see you online on Friday morning.
All right, thank you.